Creating a true thinking artificial intelligence, it's got to be one of the greatest scientific quests in human history, right? I mean, this is a milestone that's going to change literally everything we know. And look, that's not me exaggerating. AI pioneer Rich Sutton put it perfectly. He said achieving it will be comparable in significance to the rise of life on Earth. Just let that sink in for a second. That's the scale we're talking about here, the very origins of life. So it makes you wonder, what if the path to getting there isn't about building some unimaginably bigger brain? What if it's actually about learning, like a baby? What if the secret isn't what we cram into a machine, but what it can figure out all by itself? Okay, so to really get our heads around this pretty radical idea, we've got to dive into a huge debate that's been raging at the heart of AI research for years. And it all comes down to one question. How do you even start to build a mind? So you've basically got two camps. On one side, you have what's called design time learning. This is the approach we're all pretty familiar with, right? You take an AI and you just load it up with massive amounts of human knowledge, kind of like a digital encyclopedia. It knows what we've already figured out. But then you've got the other side, runtime learning. And this is totally different. The idea here is that the AI starts with almost nothing, and it just learns continuously from its own experience, kind of like a kid exploring the world for the first time. And why is this runtime idea so important? Well, it boils down to something called the big world perspective, and it's actually super intuitive when you think about it. The world is just unbelievably complex, right? It's messy, it's unpredictable. There's no way you could ever pre-program an agent for every single thing it might encounter. It's impossible. So for an agent to be truly intelligent, it has to be able to learn and adapt on the fly as it bumps into new stuff. And this is a really fundamental shift in how we think about AI. The goal here isn't to build a perfect static library of everything humans already know. No way. The real prize is to create a partner in discovery, an agent that can learn like we do and uncover things we haven't even thought of yet. Just think about an infant playing. It might look random, but it's not at all. They're basically little scientists, right? They're constantly running experiments. What happens if I shake this rattle? What sound does this thing make when I drop it? They're creating their own little problems to solve, and it's all driven by this incredible curiosity to just understand and control their little world. That right there, that's the absolute essence of runtime learning. Okay, so that's the big idea, an AI that learns like a kid. But how in the world do you actually build something like that? What does the blueprint for that kind of mind even look like? Well, we start with a model that's pretty standard in the field. Think of it as the 4 basic food groups for an intelligent agent. First, you need perception, so it can see and make sense of its environment. Then you need a policy, which is just its game plan for what to do. You also need a value function, which helps it figure out if things are going well or badly. And finally, you need a world model, so it can actually plan ahead and predict what might happen next. All right, now here's the first big upgrade. We introduced the idea of subtasks. So instead of having one single massive goal, the AI can break things down. It can learn and manage a whole bunch of smaller skills or options all at the same time. You can think of it like a person learning individual skills: how to walk, how to talk, how to pick something up. Each one is an option that can be combined later to do much more complex things. And that brings us to the whole shebang, the OAK architecture. OAK stands for options and knowledge. And you have to understand, this isn't just a static diagram. This is a blueprint for a mind that learns to learn. It's a dynamic, self-improving system that's built around a constant cycle of discovery. So what's the engine that drives this whole thing? It's this really cool discovery cycle. It's a continuous loop. So it all kicks off when the agent just notices something interesting. Could be anything, a weird sound, a flashing light. Then it creates a little subtask for itself, like, hey, how can I make that happen again? It then learns a new skill, an option, to solve that subtask. And as it learns more and more of these skills, it builds a richer model of how the world works. And then, and this is the genius part, it uses that new, smarter model to plan and discover even more interesting features to investigate. It's a feedback loop that lets the agent basically write its own curriculum, always pushed forward by its own curiosity. And look, this isn't just some high-in-the-sky philosophical idea. There is a very concrete and honestly kind of surprising plan for how to actually get there. Get this, the core strategy of what's called the Alberta Plan is to retreat. Yeah, you heard me right. Retreat, retreat, retreat. The idea is to go all the way back to the absolute basics, the most fundamental learning algorithms, and just rebuild them from scratch, but this time making them perfect for this kind of nonstop, lifelong learning. So this whole plan breaks down into 4 big phases. Step 1, relearn the basics. Like we said, they're going back to square one, redesigning those fundamental algorithms for a world of continual learning. Step 2, revamp the core. They're retooling all those key AI components, prediction, control, planning, to work in this new big world way. Step 3, build the prototype. This is where they put all the pieces together and build the first agent using that oak architecture. And finally, step 4, the ultimate goal, amplify intelligence. That's where you take this newly created AI and integrate it with our own human minds. And that final step is so important because it points to a future that looks very different from the usual sci-fi tropes. It's less about building some separate, godlike AI that lives in a box and way more about forging a real, genuine partnership with humanity. This is a concept called intelligence amplification. The whole point isn't to replace us, it's to augment us. And this could look like a lot of different things. It could be a super tight integration, like an intelligent prosthetic limb that learns and adapts right along with you. It could even be something wild, like a new artificial lobe for your brain that expands what you're capable of thinking. Or, it could be a looser partnership, like a deeply personal assistant that truly understands you and literally grows with you over your entire life. So you see, when you really get down to it, this vision of AI is fundamentally collaborative, not just computational. The goal here isn't to build a better calculator or a fancier search engine. We're trying to build a partner in discovery, a new kind of mind that can help us see the universe in ways we never could on our own. And all of this leads to one final, really profound question that I'll leave you with. If an AI creates its own goals, if it learns through play and exploration, driven by its own curiosity, just like a human child, well, where does the line between programming and parenting even begin? Something to think about for sure.